So on the L'Hopital side, let's look at number 1. We have the limit as x goes to 0 of sine x over x. And we know that that is 1 because we know there's a theorem that says that's 1. But say we forgot. Sine of 0 is 0 and 0 is 0. So you do have 0 is 0. So you can use L'Hopital. So the derivative of sine x, this would be the limit as x goes to 0, would be cosine x over 1, which cosine of 0 using direct substitution is equal to 1. So that was number 1. Number 2 is the limit as x goes to 0 of 2x minus sine x over x. Now, this would be 0 minus 0 over 0. So you can use L'Hopital, the derivative of the top. So the limit as x goes to 0 of 2, and the derivative of sine x is cosine x, so minus cosine x over 1. And when you get that over 1, you're like, yay, because I won't have a 0 down there. So that's equal, using direct substitution, 2 minus 1 over 1, or you get a 1. This was a negative 1, right? No, that was a 1. Okay. I got 2 minus 1, right? So you should just get 1. Next one, number 3, is the limit as x goes to 0 of the square root of 4 plus x minus 2 over 2x, which is equal to 2 minus 2 over 2 times 0, so you get 0 over 0. Now, you could probably use conjugates to solve this, but since you know L'Hopital, it's a shortcut. Let's go for it. The limit as x goes to 0, on the bottom you get 2, and the derivative of 4 plus x to the 1/2 is 1/2 4 plus x to the negative 1/2, and then times 1. So we can rewrite that. The limit as x goes to 0 of 1 over 4 square root of 4 plus x. Direct substitution gives us 1 over 4 times the square root of 4, or 1/8. So that's number 3 is 1/8. Somebody's mowing the lawn. I can't shut the window because my cat is sitting in the window and I don't have the heart to shut that poor window on her. So she's just an indoor cat. Limit as x goes to 0 of the square root of 4 plus x minus 2 minus x over 4 over 2x squared. So it would be 4, which is 2 minus 2, and then I have minus 0 over 0. So 0 over 0. I can apply L'Hopital, and I get the limit as x goes to 0 of, remember what this was 1/2 4 plus x to the negative 1/2. Can't write today. And then minus 0, and then minus 1/4, because that's 1/4 x, right? All over 4x. Okay, this is still going to be a 0 on the bottom. Let's see what we get on the top. We would have, this is 1 over 2 times the square root of 4 plus x. So that is 1/4. So 1/4 minus 1/4 is 0. So it still comes out to be 0. And of course they're going to make it work that way. That's why they did the problem this way. Notice I didn't simplify it in here, because if you have to do it again, it's better to just leave it. That would be, now bring the 1/2, the negative 1/2 down in front. So it's negative 1/4. I'm doing L'Hopital again. Negative 1/4, 4 plus x, and I'm going to take another 2 over 2 away to the negative 3/2, and then that would be 0 this time over 4. So I'm going to be okay on the bottom. So let's try to make this look nice. The limit as x goes to 0 of everything's going to be on the bottom, right? I have a negative 1 over 16, And then I have the square root of 4 plus x quantity cubed. So substituting this in, you get direct substitution -1 over 16, and it still would be 4 plus 0, and 4 plus 0, oh, it's 3 to the 3, yeah, 4 plus, that's the square root of 2. I would take the square root first. The square root of 2 and the square root of 2 cubed is 8. So that's -1 over 16 times 8 is 128. So you get -1 over 128. All right, stop there.